Okay, now let's talk about the final type. So far we have talked about grouping. We have talked about how to factor a trinomial when the leading coefficient is 1. Then we talked about if we have 4 terms, then how are we going to factor them? We have to start with the grouping method, then we use the greatest common factor, and then we also talked briefly about how to use difference of squares formula to write the factors. Now we want to talk about the last type, which is when we have a trinomial when the leading coefficient is different than 1. So let us start with an example. I have an example here, 2x squared minus 7x plus 6. So we can clearly see that this is a trinomial. It has 3 terms, and the leading coefficient, the term in front of x squared, is non-different, is different than 1. It's, in this case, it's 2 actually. So if we have to factor this, before we do or use any of the other methods, we still have to look for the greatest common factor. Again, it turns out that when you compare these 3 terms, the greatest common factor is just 1. 1 is not going to help us much, so we have to figure out some other way. The other way has to do with, again, realizing the fact that this is a trinomial. So it's a trinomial. I have seen mostly people trying to, again, use the similar method that they would usually use for leading coefficient 1, like try to draw the parentheses, and then maybe instead of using x and x here, they may use a 2x and some other number here and x or something, and then they kind of try to think of other pieces that go here so that finally when they distribute, they get back to this original polynomial. That's like a hit and trial method. Does it work? It works sometimes, and it may also be a good idea to do that if you are taking a multiple choice test where you have to choose one option out of any given 4 options. But is that the best method out there? And I would say no, it's not the best method, because sometimes I have also experienced with my own students, like they spend so much time in like thinking about those 2 factors that it's not worth it. It's not worth it to just do hit and try here. Hit and trial has its significance, has its importance if you are doing a multiple choice test or at some other places. But here, I would like you to see the actual method, and that actual method is called splitting the middle term. So what we do is we split the middle term. Actually, this method, splitting the middle term, works for any trinomial, even the leading coefficient is 1. But with 1, it's easier to do it by just drawing the parentheses, putting x, and then filling in the rest. It's easier that way. Again, our goal is to try to make things convenient and easier for us, not to make them complicated all the time. But for this case right here, when the leading coefficient is different than 1, this is the method that we should actually try to use. So how does the method of splitting the middle term work? As the name of the method suggests, what we do first here is we start multiplying the constant, which is 6, again in this case as was in our previous trinomial. We multiply this constant with the leading coefficient. In this case, the leading coefficient is 2. So if you multiply 6 times 2, we get 12. So every time this procedure works, you start by multiplying the leading coefficient with the constant term. Again, if we go back to the previous case with the simple trinomial when the leading coefficient was 1, we are still actually multiplying that 1 times 6, but that does not really change this constant. So that's why we don't really say we are multiplying them, but we are actually doing the same thing. We are multiplying the constant with the leading coefficient. Again, we do the same thing here. 6 times 2 is 12. And now we try to come up with 2 factors of 12 that add up to -7. So it's still the same deal that we did with the simple trinomials when the leading coefficient was 1. So to come up with 2 factors of 12, sometimes some of my students, some of them can quickly figure that out. Some of us cannot figure out those 2 particular factors. So in that case, I would suggest write some factors, whatever comes to your mind, starting with the smallest one. So with 12, I would start with 1 and 12, because 1 is a factor of almost every number. If 1 and 12 works, of course, -1 and -12 is also going to work. But whether it's 1 and 12 or -1 and 12, they do not add up to -7. So this does not work. I'm going to cross that out. Moving on to this next factor of 12, which is 2 and 6. Well, 2 times 6 is 12, but 2 and 6, no way, whether I change the signs, if we add them, it's not going to give me a negative 7. It does not work either. Now my third choice would be 3 and 4. Well, now I can see some hope here. Well, 3 times 4 is 12, but 3 plus 4 is 7. We want a negative 7. So what can we do with this 3 and 4 so that it looks like negative 7? Well, if I change the sign to negative and negative 3 and negative 4, let us verify negative 3 and negative 4. Negative 3 times negative 4 is still 12, and negative 3 plus negative 4 is negative 7. So it seems like negative 3 and negative 4 actually works. So now we are going to use these two numbers to break this negative 7x into two pieces. That's why it's called splitting the middle term. Or you can think of breaking the middle term into two pieces. So the next step is 2x squared minus 4x minus 3x plus 4. Well, the other thing that you should note here, I started by writing negative 4 first and negative 3x. It does not really matter. If you want to write negative 3 here and negative 4 here, you are still going to get the same factors. So it does not really matter which one you write first. Well, there was a reason for me to write negative 4 first, because I saw this 2 here. So that made me think like I should put a 4 next to 2, because the next step that you have to do here is, oh sorry, I have to put the 6 here. The next step that you have to do here is you have to use the method of grouping, because now how many terms do you have? You have 4 terms. Whenever you have 4 terms, what is the method that we know that works? It's the method of grouping. So let us go ahead and try to group these two and these two. So if I group these two, I can clearly see that the greatest common factor is 2, between 2 and 4. But between x squared and x, I also have an x as the greatest common factor. So I have 2x as the common factor, as the greatest common factor. What is left inside the parentheses? For the first term, it is x. And for the second term, it is minus 2, because 2x times x is 2x squared. 2x times negative 2 is negative 4x. So that takes care of the first two pieces. For the second two, remember the negative, we have to keep that negative. We don't change anything with that sign. Between 3 and 6, the greatest common is only 3. If everything is actually going to work out here, then we already know that what goes inside this parenthesis is going to be the same as what is already in this parenthesis. So let us actually put x minus 2 here, and now verify whether this is the right factors. Negative 3 times x gives me negative 3x. Negative 3 times negative 2 actually gives me positive 6. So that means these and these are the right factors. This guy and this guy right here again looks the same. If they are the same, they are again the greatest common factors. What do we do with them? We just write them out. And then we have a 2x left from the first piece, and I have a negative 3 left from the second piece, and I have, these are the factors. And why would I say these are the factors? Because they are already linear terms. This is a linear term. There's no common factor between these two. This is also a linear term which does not have a common factor. So we can say that this is the final simplified form. This is the final factors for this trinomial. This method requires a little bit more work, but this is a method that actually works. This is a method where you don't have to do hit and trial, and you don't have to just think about the numbers that fit in to get us back to this. This is a very good method that starts with breaking the middle term, using the grouping method, which you have already learned in the previous video, and then just writing out the factors. Okay, so this takes care of the 5 different types of factoring. In the next video, I'll be talking about a method to find the solutions, the method when these 4 different types of factoring methods do not work. Okay.